Assalamu alaikum students. Today's topic is going to be about charging and discharging of a capacitor. But first of all, what is a capacitor? A device which stores charge and its energy is known as a capacitor. Let's see how it works. Charging. Now here is a simple diagram of two capacitor plates and it is connected to a circuit. Here the two switches are S1 and S2. The larger line is representing the positive terminal and the smaller line is representing the negative terminal. Now, as the switches work, as you can see, they are open. Now the circuit won't work. But if we close S2, now the circuit is complete and the charge is beginning to flow through the wires. Let's say the positive charge moved from the positive terminal of the battery to one side of the parallel plate capacitor. Now, as the charge are being developed and being deposited on the parallel plate capacitor, there will be a time when no more charge can be developed on the capacitor and it will be its maximum value. And that will be represented by Q0. Like over here, this is the last charge and there will be no more space on the plate for any other charges. As there are positive charges on one plate, there will be negative charges on the other plate. Now, in this case, we have to represent mathematically what is going on. So, at any time t, we have a charge Q and a current I. And we know the concept of Ohm's law that V is equal to IR. But over here, we have the EMF, which is represented by V0, and the potential of this capacitor, which is V, which has the formula Q over C. This formula basically came into place when we saw that the more charge we put on the capacitor, it is directly proportional to the potential difference of that plate capacitor. And if we convert that proportionality into equality, there's a constant proportionality known as capacitance. So if we rearrange it, that will be Q over C will be equal to V. And that is why we are going to write that V is equal to Q over C. So V0 minus Q over C, because we said that V is equal to Q over C, is equal to IR. Now, if we rearrange it, it will be V0 minus Q over C minus IR is equal to 0. Or we can rewrite it down as V0 is equal to Q over C plus IR. So now in this case, if we want to rearrange this whole equation in a very similar form, we say main voltage equation. Now in this case, we have to assume that after it reaches maximum charge, which we say maximum point charge, which is Q0, that means no more current will flow through the circuit. That means already the charge has been developed. Why it does it need more charge? It will not flow, the current won't flow. And as the current won't flow, the current will be equal to 0. Now, if we put this value of I equal to 0 in this equation, what do we get? V0, let me clear it out for you. V0 is equal to Q0 divided by C minus 0 R. Or we can say V0 is equal to Q0 over C. Now, in this case, putting this V0 in this equation, we get Q0 over C is equal to Q over C plus IR. Now, in this case, we represented by Q0 minus Q0 over C minus Q over C is equal to IR. And as the LCM is same, so we can simply write it down as I is equal to Q over delta T. It means current is equal to rate of change of charge divided by rate of change of charge, sorry. Now, in this case, we can see the denominators are same, so we can write down the whole equation in another form. So it will be Q naught over C minus Q over C is equal to delta Q over delta T. And we can represent it as Q naught minus Q over C because the denominators are same, that's in same, delta Q over delta T. And if we rearrange this whole equation, what we get? We get 1 over RC, so C goes to the other side, it will be RC, and it goes to the denominator part, 1 over RC into dt. So instead of writing down like this, delta T, we can say it is dt. Let us write it down over here that how it is formed. Q over C is equal to delta Q divided by delta T into R. This C goes to the side, it will be Q naught minus Q into delta T is equal to, divided by this, delta Q will come over here. And this C goes to the side, it will be Q R C divided by delta T already has gone over there. Now, if we rearrange this whole equation, what do we get? This RC goes over here, and this Q naught minus Q will go over here. So we can rearrange this whole equation in this form. That means 1 over RC dt is equal to 1 over Q naught minus Q dq. Or we rearrange it to 1 over Q naught minus Q dq is equal to 1 over RC into dt. Now, if we integrate on both sides with a lower value of 0, that means when there was no charge to the maximum value at any charge point, so we'll get 1 over Q naught minus Q into delta dq is equal to, when there was no time and there's any time t, 1 over RC into dt. Now, in this case, we are going to integrate by using a formula of integration, that integration of 1 over x into dx will be equal to log of x. So similarly, if we have to divide by an algebraic value, 1 over a x plus b. So as you can see, there's a positive sign over here with respect to x because we are integrating with respect to x, and there's a differential present on top. So we can represent it as log of ax plus b. But in our case, we have a negative sign over here. So what do? We multiply it by a -1 and we divide it by a -1 over here as well, on top and bottom, denominator and numerator as well. What do we get? We get log of Q naught minus Q with a lower limit of 0 to Q, and there's a negative sign over here because of the integration. And we get on the other side 1 over RC into T because we are applying the derivative of T. So integrate of, let's say, dx. If we integrate it, it will be of x. That means integration of 1 will be equal to x. So there was nothing over here, just 1. So we integrated with respect to T, we got T over here. We are applying the value of T, 0 and T in this whole equation. What do we get? We get minus log of Q naught minus Q minus Q naught minus 0 is equal to T over RC. Now, if we rearrange this whole equation, we get log of Q naught minus Q minus log of Q is equal to T over RC. Now, if we apply the formula of log over here, what do we get? Because there's a negative sign in the formula of log, we can divide the first part by the later on part in a very simple way. So we get log of Q naught minus Q divided by Q naught is equal to minus T over RC. Now, if we take the anti-log on both sides, that means E over here as well as E over here. So this E and this natural log of E, which we cancel out, taking anti-log on both sides. What we are left with is Q naught minus Q divided by Q naught is equal to e raised power minus T over RC. And we can represent it as Q naught minus Q is equal to Q naught e raised power minus T over RC. Taking Q naught to the other side, we get Q is equal to Q naught minus Q naught e raised power minus T over RC. Taking these Q naught common, what do we get? We'll get Q is equal to Q naught 1 minus e raised power minus T over RC. Now, this is the equation for charging, which can be represented over here very clearly, which is the equation for charging at any instant. That means at 0 point, at 1 second, 2 second, and when it was fully charged. Now comes the part of the discharging. In this case of discharging, we have two plates over here. They are already fully charged, as you can see over here. Now, in this case, we have to discharge these charges from one plate to another. So, as we told you that it is S1 and this one is S2. In the first case, in the case of charging, we close S2. So, basically charged. Now, in the very next second case, we can say these plates are going to be closed, but one at a time. So S1 we are closing right now. So S1 is closed. So in this case, we can see the charge is going to flow from the positive terminal towards the negative terminal like this. And it will keep on flowing again and again. Now, again, if we draw a graph over here with respect to time, this. We already have reached a maximum point, which is Q naught, and it keeps on decreasing as the time goes by. So as the time goes by, the charge on the capacitor basically decreases. Now, how can you find out it mathematically in this case? So now our capacitor is totally charged in the first case. So we have again the formula V is equal to Q over C, where this V is basically represented by V naught, which was the maximum voltage, which is of the capacitor. Not V naught actually, is the voltage of the capacitor, which is maximum, minus Q over C. Now in this case, as there is no voltage supplied over here, because we have not connected it over here, so this whole thing, V naught, will be equal to 0. Because the voltage was, the EMF was not connected actually. So 0 minus Q over C is equal to IR. As I, we already know by the definition of current that it is the rate of change of charge. So delta Q divided by delta T. Putting this value in this equation, we get minus Q over C is equal to delta Q over delta T into R. And we can rearrange it like before, like minus Q over C is equal to delta Q over delta T into R. So in this case, we can simply say that minus 1 over RC, that means R goes over here, into delta T, T goes over here, is equal to 1 over Q delta Q. And we can represent it very simply as RC into delta or dt is equal to 1 over Q dQ. So this is the equation which we have at that end. Taking integral on both sides to basically sum this whole up, what do we get? Integral from when there was no time, time is equal to 0 to time t anytime, minus 1 over RC is equal into dt is equal to when there was maximum charge. That means the starting of the experiment when there was maximum charge Q naught, to when there was little bit charge left at the end, which is Q. It can be any charge, number of charges which is present inside the capacitor. If you apply the integration, we get 1 over RC and T, because integral of T, 1 is basically T. If we apply the integral of 1 dt, answer will be equal to T, simply. Applying the power rule, you can say. So 1 over RC into T from 0 to T is equal to log of Q from lower part Q naught to maximum part Q. Because there is a derivative present on the top, so we'll say that log of Q is to be used, like in the previous case, in the case of charging as well. Now, if we rearrange it and write it down in proper manner, the higher value will be written first. So minus 1 over RC into T minus 1 over RC into 0. So this whole thing will be equal to 0. In this very similar manner, the log of Q minus the lower value log of Q naught. Now, if we rearrange it, we get minus T over RC is equal to log of Q, because this is before, minus in log can be written in form of deviant form, so Q over Q naught. Now, in this case, we can simply take the anti-log on both sides, but if we want to take time constant, that means it will be 1 over RC into T is equal to minus log of Q naught over Q, because if you want to put this value on top, then it will be log of Q naught minus log of Q 4 power negative. If we take negative common in this case, then it can be written like this. So it will be negative will be cancelled. It will be 1 over RC into T is equal to log of Q naught divided by Q, or we can figure out the time in this case. In this case, that it will be equal to RC into log of Q naught divided by Q. But if we want to simply find out the formula for discharging, then we are taking the anti-log on both sides. Very easy. Taking anti-log over here, anti-log over here. This anti-log and log will cancel out. We'll get E raised to power minus T over RC is equal to Q over Q naught. And if we rearrange it, it will be Q is equal to Q naught into E raised to power minus T over RC. So this is the equation for discharging actually at any instant which you are going to use. I hope you enjoyed today's lecture. I certainly did. Meet you in the next lecture. Allah Hafiz and bye-bye.